Assalamualaikum warahmatullahi wabarakatuh. I am Farhan Hasan. So today I will explain for our first group assignment, which is to apply using Hebbian and Adeline training algorithm to the set data. So this set of data we need to reshuffle the data. For the first method, which is Hebbian training algorithm, we already set the data into random order, which is we reshuffle the data. So the learning rate for this method is 0.4, and the value of t is classified by the class of the data based on the question. So for the class A, the data will be 1. For the class B, the data will be 0. So the value of y will be equal to t. So value in the y column will be same to the t column for the epoch 1. So the initial wave for this method we already set to wave 1 equal to 1, wave 2 1, and the bias also 1. So to start this method, we need to find the value for the new wave. We use this formula to find the new wave, which is W all 1 will plus with the learning rate multiplied by the value of x, which is 1, and value of y 1, and we got 1.4 for the wave 1 of the new data. So we'll repeat the same by using same equation for the W2. And for the bias, we use this formula. Bias all 1 plus learning rate multiplied by y. So we get 1.4 for the new bias. So we'll this method by using we repeat until all the data has been calculated. So in this method we do until 50 epoch. So we find the wave 1, wave 2 and bias until 50 epoch, and we take these three values to find the threshold. So to find the value of y here, we use this formula. 1 multiplied by 1 plus W2 multiplied by 2 plus bias 61. So we will get 143. We repeat this method by using this equation for the to determine the value of y in this column. So determine the value of threshold 102 and 61 and divided by 2. So we able to get 81.5 for the value of threshold. So from the value of threshold, we apply to this formula and simplify until we got this formula have relation with y equal to mx plus c. So from this equation, we can determine the slope of this line. So we set the x from negative 1.5 until 1.5, from here to here. And then we insert the value of x1 into this formula, and we able to find the value of 2. The negative 1.5, we got value 2 for the x2, which is here. And same, negative 1, 1. Negative 0.5, 1. 0.5, 0. 0.5, 0. 1, negative 0.5. 1.5, negative 1. So, we are able to do the Hebbian training algorithm to this set of data. That's all for me. Thank you for watching.
Assalamualaikum, my name is Syahirah binti Razali. So I will be discussing about adaptive linear element, which is also known as Adeline learning algorithm. Briefly, this algorithm is a single neuron model which uses a linear activation function. In this case, as you can see here, this is the architecture of the Adeline neuron model. Adeline neuron model. So it usually has a feedback or also called as error, which will be fed back to its input. This Adeline also computes the sum of its weighted inputs and passes the result through a linear transfer function. So the first step in solving this problem is that we need to initialize the weight, and also we have to set the learning weight as this. For this solution, we set the learning rate as 0.3. We can get the value of x1, x2, and t in the question. T belongs to its classes. How do we find s? In order to find s, we need to calculate using this formula. As for the first step, w1 times x1 plus w2 times x2 plus b, and we will get the value of s, which is 2. And then we have to make the t minus s power of 2. How do we find the value of w new? In this case, we need to use this formula. For example, 0.5 as its whole value plus alpha is also known as learning rate, 0.3 multiplied by t minus s, multiply also to x1, then we will get 0.2. This is also same as the step of getting the value of w1 new. As for b, we use this formula. B new equal to b all plus alpha in bracket t minus s. In order to find b all 1 plus 0.3 times negative 1, and we will get the value of 0.7. It is just the same step to find the value of new value. In order for us to find the error, we need to use the formula of summation of t minus s squared for every iteration. Error of every iteration must be reduced. We can see that along the epoch, the value of error is decreasing. We have the same calculation for like 50 epoch. But in this case, we are focusing on the first epoch. In this case, how do we find the value of threshold? We have to find the value of threshold. We have to take the value of y, which is nearest to the value of 0. In this case, we take the value of 0.4003 plus 0.68608, and we have to divide these two to 2. Then we get the value of 0.55305. We need the value of threshold value to be fed into the equation of straight line. As you can see here, this is the equation of straight line, which is also known as y equal to mx plus c. After this some modification, then we get the equation of this, and we tabulate the value of x1 and x2, and then we get to tabulate it in the graph. So this is the final result of this problem. I guess that's all. Thank you.